So the first thing I'm going to do is, so this is question 8, the dopamine question, since I just started recording. 70 kilograms is the patient's weight, and I'm going to multiply by the 5 micrograms kilogram minutes. Okay, this is very similar to how you start up when you're doing the Heparin protocol. You start off by doing a conversion of the patient's weight in kilograms, and then we're going to find out and account for the patient's weight. So when we do that, we get I want to say it's 350, but let me just double check. So 70 times 5 is 350. Yeah. So 350 micrograms per minute. Now, before I do anything, I have to make a decision to either convert micrograms to milligrams, or I can convert milligrams to micrograms. You can do that. And then I also need to convert minutes to hours. And you can actually do that all using dimensional analysis as you're working through this. So what I'm going to do is I'm going to go ahead and convert this to milligrams per hour. So what I'm going to do is I know that 1,000 micrograms is equal to 1 milligram. So that'll help me convert from micrograms to milligrams. And the reason I'm doing that, just if you're not following, is because my available is in milligrams. Okay. You can also convert milligrams to micrograms in the available. That's perfectly fine. There's not just one right way to answer this, but that's just the way I'm choosing, just because I already started here. And I just wanted to show you what this would look like if you were to do this dimensional analysis wise. Now, instead of calculating anything out, I'm actually going to go ahead and just add another dimensional analysis element, and I'm going to calculate and convert minutes to hours. Okay. And for those of you who've been working with me over the years, you know that the reason I show this in dimensional analysis is just because it gives me a way to just kind of visually show you what I'm doing. Okay. So if you don't like it, it's okay. There's 100 different ways to answer these questions. I'm just showing you what I did. So if you did this stepwise and you're going to come up to the same answer, as long as you got the right answer, you're doing it right. So don't get hung up on the details. So I'm going to take that 350 times 60 and then divide that by 1,000. And I'm going to get 21 milligrams per hour. Okay. Now that I have milligrams per hour, I have a way to go from milligrams per hour to milliliters per hour with my available dosage. So what I'm going to do is I'm going to take that 21 milligrams per hour, and I'm going to multiply by my available, and I want to get rid of milligrams. I want to convert it to milliliters. So 400 down here, 250 up here. I'm going to take 21 times 250, which gives me 5,250. And then divide that by 400, and I'm going to get 13.125 milliliters per hour. When we have a number greater than 1 with a decimal, we're going to round that to the nearest tenth. So we would just round that to 13.1 milliliters per hour. And then I just want to double check that your key says that same thing. Oh, okay, so they left it at 13.125, but that's probably because I'm assuming when the key was made, they didn't make a decision on rounding that to the nearest tenth. So to my knowledge, you would round that to the nearest tenth. But if it were me and I wasn't 100% sure, and this is me telling you I'm not 100% sure, write this out. So write out the 13.125 milliliters per hour, which you got, and then that you would round it to 13.1 milliliters per hour. And at least you could argue your point that you were told to round to the nearest tenth in case they tell you that this is the answer and you shouldn't have written this. You can at least argue that point and be like, well, I did write that. I got the right answer. And then this is the rounding. Because I do believe on an infusion pump, like when you're programming that in, I don't even know if you can go to the 10th. But that's how they wanted us to, or how they the nursing department wanted me to give you guys your answers by practicing rounding for these math type things. So, all right. Someone else mentioned number 11. Let me pull that up. So number 11 says that your patient has congestive heart failure and is ordered furosemide 200 milligrams IV daily. The available dose is furosemide 100 milligrams IV. The label reads furosemide 30 milligrams per milliliter. How many milliliters of the drug will you give? So there's a lot of numbers here. Okay. So this is number 11. So the order, it says the order is furosemide 200 milligrams and the available is furosemide 100 milligrams IV with the label reading 30 milligrams per milliliter. We don't really care, at least from the math standpoint, whether it's 100 milligrams IV, 1,000,000 milligrams IV, 1 liter milligram IV, that doesn't matter. What matters is how is it administered? What is the concentration? And then what is the order? So the order is 200 milligrams. And then we just factor in the conversion of 30 milligrams per milliliter. 200 divided by 30 will give me 6.666 repeating. And then we would round that to 6.7 milliliters. So that 100 milligram or that 100 milligram IV is just a distractor. It's just basically telling you that what it is and that it's there. That doesn't necessarily mean you need to do anything with it. So don't let those distractions get you. Just remember, it's always the order and then the concentration and the strength that you need in order to do it. It's the way I wrap my head around it is like, think about a, like a bottle of Tylenol. You have Tylenol and let's say there's, 500, tablets in there, or capsules in there. I don't even know if that, maybe it's 300 capsules in it. But, you're going to give them 2 per dose. You're not going to give them the whole bottle. And so that's all that it is. So, anyways. All right. Then 16. 16 is another IV question with a drop factor involved. So 16 says we have an IV of 500 milliliters dextrose, 5% water to infuse at 120 milliliters per hour with a drop factor of 15. What is the drop rate? So as a reminder, when you do drop rates, when you're calculating drop rates, you need 2 pieces of information. You need the flow rate and you need the drop factor. Once you have those 2 pieces of information, you can calculate the drop rate, which is in drops per minute. Okay. So it says we have something infusing at 120 milliliters per hour. Now, ultimately, I want this in minutes. So what I'm going to do in order to kind of simplify the process, 120 milliliters per hour, and then I'm going to do 60 minutes because 60 minutes equals 1 hour, right? Then I'm going to multiply by the drop factor, which is 15 drops per milliliter. And then I'm going to get 30 drops per minute. And you would just calculate 120 times 15 divided by 60, and that would give you the answer. Or what I did in my head is I reduced 120 over 60. So 2 times 15 is how I got to 30, just in case you were wondering, my thought process. All right. Question 21. And I'm going to go ahead and flip this over and I'm going to switch paper here. And again, I'm just going off of what questions were posted on here. So I think I'm going to cover everything here. So just be patient. All right. So 21 Your patient is to receive Solumedrol 200 milligrams IV. So that's your order. It is received from the pharmacy in a 120 milliliter bag of dextrose 5% water to infuse over 30 minutes. The drop factor is 10. No other IVs are running. What is the correct drops per minute flow rate? So here's where we have another extra piece of information that's not new, and that is, another piece of information that is not needed, and that is the 200 milligrams IV. So even though that was the order, we are basically just calculating the flow rate in this question. So it's extra piece of information. We need to know two things: flow rate and drop factor. The flow rate, and this is question 21. So let me just bring this down. So the flow rate is the 120 milliliter. And then it said over 30 minutes. Okay. So the 120 milliliters over 30 minutes. Hold on one second, guys. Let me just mute this.
Yeah, let me see.
Okay. All right. So the 120 milliliters over 30 minutes times the drop factor, and the drop factor is 10. Okay. So 120 over 30 is the same thing as 4 times 10 is 40 drops per minute, or multiply 120 times 10 divided by 30 and you'll get to the same answer, 40. But in question 21, the extra piece of information is that 200 milligrams of the Solumedrol. We don't need to know that information in order to calculate flow rate. The only thing we need to know to calculate flow rate or drop rate is the flow rate in milliliters per hour, or in this instance, milliliters per minute, and the drop factor. Yeah, and someone asked about new types of questions. If any new questions I create, they'll be in the practice test folder on the OneDrive link that I posted in the chat. And actually, the practice test you have here is actually some of the newer questions. So you have, I think, the newest questions here that they're asking you. And then the practice folder has some additional questions that are different than what's listed here. So, all right, 22 is, I always say these questions like 22, 23, 24, these are warm-up questions for the heparin protocol. Okay, so 22 says we have heparin IV infusing at 750 units per hour, but I want to know what that is in milliliters per hour. And then I have my available bag is, or my available heparin dosage is 25,000 units per 1 liter, which is the same thing as 1,000 milliliters. So what you're going to do here is you're going to take what is given to you. So this is question 22, the 750 units per hour. Okay, times, I don't want units, I want milliliters. So I have 25,000 units of heparin in a 1,000 milliliter bag, right? Because 1 liter is the same thing as 1,000 milliliters. And then I'm going to multiply across the top, 750 times 1,000. Then I'm going to divide by 25,000. And I'm going to get 30 milliliters per hour. And like I said, this is very similar to the heparin protocol. In fact, that's essentially what this is. It's just a piece of the heparin protocol calculating the heparin drip. All right. Did anyone need to see 23 or 24? If so, just put it in the chat box to do 23 and 24. Otherwise, we'll go ahead and do the heparin protocol. Okay. Yeah, thank you for asking. Okay, so 23 and 24, good. Okay. I figured if I asked, you'd want to see it. So, all right, so 23, again, just a warm up for the heparin protocol. I'm sorry, I wrote 23. I wrote 24. So I'll do 24 first and I'll come back to 23. So 24 is still very similar to the heparin protocol, but we're going to be talking about insulin here. So it says your diabetic patient requires 0.9% normal saline, 500 milliliters with 100 units regular insulin, infused at 15 units per hour. What is the flow rate in milliliters per hour? So I'm going to take my 15 units per hour. Then I don't want units. I want milliliters. And I have 100 units per 500 milliliters. And so what I'm going to do is I'm going to take 15 times 500, get 7,500, and then divide by 100. And I'll get 75 milliliters per hour. And then for 23 says we have heparin IV infusing at 1,250 units per hour. But we want it in milliliters per hour. And it says we have 500 milliliters with 25,000 units. So I'm going to do the same thing. I'm going to take the 1250 times 500, which gives me 625,000 divided by 25,000, which gives me 25 milliliters per hour. So again, I apologize for going out of order with 23 and 24, but I have them numbered correctly, which is really good. Okay, heparin protocol. Now, if you don't know this already, I've already worked this out a couple times on my YouTube channel. So by all means, review that after we do this. With the heparin protocol, just as a reminder, because I know you guys saw this last semester. Actually, I get the formatting on that is horrible. All right. So the heparin protocol looks like this, where you have the protocol is stated, bolus the patient with heparin 80 units per kilogram body weight and start a drip at 18 units per kilogram per hour. I know you can't read this very well, but you should have a copy of this. The patient's weight is 110 pounds, and then we look at the protocol. Now, I circled here what are the important components of the protocol for you guys. We don't need to worry about steps 3 through 9 because we're not filling these in. That's not part of the math test, okay? But we do need to convert the patient's weight into kilograms if it's not already provided. We need to then use the available dose of the 25,000 units in 250 ml half normal saline. And then our bolus dosage strength is 1,000 units per milliliter. And then down here, step 10 restates what it says up here to bolus the patient with 80 units per kilogram. And then to start them on a drip at 18 units per kilogram per hour. I know it says drip and it's not written in drips, but just to kind of give you a heads up on that. And then step 12, we'll come to that in just a second, but that's what that looks like. Okay. And then before I move forward, someone just asked a really good question about rounding. So if you go to the beginning of the packet tells you all the rounding rules. So the only thing that you would need to worry about rounding to the nearest whole number are drops. So like when you do drops per minute, you can't have decimal drops. You have to have a whole drop. So whether that's, so if you got, for some reason, you got like 41.99 drops, it would be 42 drops when you do that. So that would be the rounding. Everything else you would round to the, if it's a number greater than 1, so let's say it's a number like 1.25, you would round that number to 1.3, okay? You would round it to the nearest 10th. If you have a number less than 1, like 0.125, you'd round that number to the nearest 100th, so you'd round that number to 0.13. So instead of just saying that, let me write that down. So when we have, so for rounding, okay, if they're drops, whole number. Okay. If they're drops, whole number. If it's a number greater than 1, such as 1.25, you would round that number to 1.3. Again, the caveat to that is if it's drops. If this were drops, then you well, hopefully you don't get that. That shouldn't be a choice, at least on the tests that were created here at CCAC. My guess is that you would round down to 1 if that happened to be the case. But you might want to clarify that with your instructor. Like I said, I wrote the test a while ago. There shouldn't be any drop factor questions that end in a decimal answer on the practice or on the tests that were created, just to kind of give you a heads up so you don't have to worry about that. Less than 1, such as 0.125, you would round that to the nearest hundredth place. So it would be 0.13. Okay. Basically, you want to have, when you can, 2 significant digits listed. So 1.3, 0.13, there's 2 significant digits here. Now, if you have something that's like 1.0, then that's, it's 1. You don't need to write the 0.0. If it's there, you don't need to use a 0 as a placeholder. But you should have a 0 when you are doing decimal answers such as that right there. So that was, someone asked that in the private message, and I just wanted to review that with you guys. Okay, so Heparin Protocol. So again, you have a patient who weighs 100 pounds. So you need to convert the patient's weight to kilograms. So you're going to divide by 2.2, and the patient's weight would be 50 kilograms. Now, when you're taking the test, the only way that I can really change the test question is by changing the patient's weight. So if you want extra practice, use your weight, your friend's weight, your dad's weight, your mom's weight, your aunt's weight, a fictional weight. Just use another weight other than 100 pounds, convert it to kilograms. When you convert to kilograms, make sure you round to the 10th place. So if you got 50.25, you would round that to 50.3 and use that in your calculation for solving these problems. I have done at least one additional version of this where I changed the patient's weight. It's on YouTube already. And then if you want to email me the weight that you do and you want to check your answers, just send me an email and I'll make sure to confirm what you got, that it's the same thing I got. Okay. So now that we know the patient's weight, 50 kilograms, now we can start solving the equations. So step A, or part A of the protocol, says, what is the bolus, or calculate the milliliters to administer for the bolus. Okay. So the bolus, in order to calculate that, we need the patient's weight in kilograms, and then we need to multiply by the bolus dosage strength, which is 80 units per kilogram. Again, we're not guessing that information. It was told to us at the beginning of the protocol, 80 units per kilogram body weight. It's told to us again in step 10 to bolus with 80 units per kilogram. Okay, so we don't have to guess about that. It tells us what to do. I know the trick is you never seen this, you never worked with this, but that's why you have me to show you what to do, I guess. And then just follow these steps. It's the same every time. We get 4,000 units. If the question had asked how many units to administer, we'd be done, but it said how many milliliters. So we need to be able to convert units to milliliters. We're going to do that by looking at what we have in the bolus dosage strength. So we look at step 2 of the protocol. Bolus dosage strength, 1,000 units per milliliter. 1,000 units per milliliter. And my answer for part A is 4 milliliters. So again, the only thing that's going to change in this question would be the patient's weight. So whatever the patient's weight is, that'll determine what the outcome of this is. You would still multiply the patient's weight by 80, divide by 1,000, and that would be your answer. Again, reminder, round to the nearest 10th in these answers as well. Yeah, someone said it's 110 pounds. That is correct. Yeah. Oh, okay. Yeah, I see what you're saying. There you go. Okay. All right. Part B says to calculate the infusion rate in milliliters per hour for the IV drip. Again, same patient, same weight, times the infusion rate, which is 18 units kilogram hour. Again, I'm getting that from the protocol. Going back to the protocol, it tells us twice, start a drip at 18 units per kilogram per hour. And then step 10, start a drip at 18 units per kilogram per hour. Once we do that, we get 900 units per hour. And then this is what I was saying, like the questions 22, 23, 24 are warm-up questions because you already practiced this, converting units to hour to milliliters per hour. And you also did it with heparin, right? So in step 2 of the protocol, it tells us the conversion is 25,000 units of heparin in 250 milliliters half normal saline. When I do that calculation, 900 times 250 divided by 25,000, and we get 9 milliliters per hour. Then, oh, okay. And then also on your test. So on your test for the Heparin protocol question, you'll have 2 questions to answer. The whole question counts as 1 question. So if you happen to miss both questions, which you won't miss, but if you happen to miss both, it only counts as missing 1, just to kind of give you a little peace of mind. But you're going to get it right because you're going to practice it and you're going to have it down. You're only going to get either A and B or C1, C2. So you're not going to get both. Okay, you're only going to get one or the other. So part C says after 6 hours, we test the patient's APTT, and it says 43 seconds. 43 seconds fits in the range as illustrated in step 12. So step 12, APTT between 36 and 44 seconds. And it tells us to rebolus with 40 units per kilogram and to increase the rate by 2 units per kilogram per hour. So C2 or C1 tells us to calculate the number of milliliters to prepare. And this is supposed to say for the bolus dose. And then part 2 is the number of the new infusion rate in milliliters per hour. So let's calculate the new bolus. So this is C part 1. Same patient, same weight, but we have a different bolus dosage strength. Now it's 40 units instead of 80. This gives us 2,000 units. And we convert that to using the same bolus dosage strength, 1,000 units per milliliter, and I get 2 milliliters for the bolus dose. If you just automatically did, well, it's 80 is half, or 40 is half of 80, 4 and then 2, then you did that right. But sometimes A, they might want you to show your work, and B, you don't want to follow that same methodology when you're doing flow rate, okay? Because that just changes how you answer that question. So for the flow rate question, for C2, same patient weight, it told us to increase the flow rate by 2 units per kilogram per hour. Our starting is 18, so our new is 20 units kilogram hour. That gives us 1,000 units per hour. Again, very similar to questions 22, 23, 24, where you go from units per hour to milliliters per hour. In order to go to milliliters per hour, I need to have a way to convert units to milliliters, and I do. I have available the 25,000 units in the 250 ml half normal saline, and then I get an answer of 10 milliliters per hour. So again, the only thing that I can really change is the patient's weight. So on your test, you might see 200 pounds, you might see 176 pounds, you might see you know, some other weight, and then you just round it to or you convert it pounds to kilograms, and then you just plug it into the system here. I know I make it sound very easy, but I've also been doing this setup over and over for many years. So if you're not getting it, just practice it. You got it last semester, you'll get it this semester. And if there's any other questions, please just let me know. Either type it in the chat box or unmute and just let me know what other questions you might have. You're welcome, Ashley. Yes, someone asked if we went over dopamine. We did. The recording will be on YouTube. So just if you click on my YouTube link and just save that, you don't have to subscribe. Just make sure you go back. I'll have it posted this afternoon once I get a chance and after it downloads and everything, or uploads, sorry.
Hey, Dr. Wright, you said what folder would the practice questions be in?
The link I posted in the chat. Did you get that link?
Yeah, I opened it up.
Okay. Yeah. So the ones that I had emailed you those questions, I haven't posted those, but those are the ones that I'll put in there as well.
Okay.
Did you get that email from me?
Yes, I got it. Thank you.
Okay. You're welcome. Yeah.
Dr. Rad, I have a question, please.
Yes.
Question 16, 21, and 23.
Yeah.
For question 16, we did not use the 500 ml D5W, but for the 21 and 23, we used the DSW figures. Can you please help me understand that?
Okay, so for 16, okay, yeah. So for 16, because it's a flow rate question or a drop rate question, we don't need to know the total volume. So that's why we don't account for it. We just need to know the flow rate and we need to know the drop factor.
Oh.
For those other questions like 23, the reason we use that 500 milliliters, the D5W, is because we need to know that in order to convert milliliters to units. Notice that the only rate here is the 1250 units per hour. So I need a way to go from units to milliliters. If they had already given me milliliters per hour, then obviously we wouldn't have a question to answer. So yeah, so the reason being is that you use it when that's the only other information you have available to you. I always use the example of if you're driving on vacation and you're going 60 miles per hour, if all you care about is how long it's going to take you to get there, it doesn't matter what you're driving. You can be in a minivan, you could be in an SUV, you could be in a little car. You don't care what it is when we're talking about flow rates. We just care about volume over time and then the drop factor. When we're doing the conversion from units per hour to milliliters per hour, we do need to make sure we have a way to do that. And that's why we account for the 500 milliliters and the 25,000 units, because that's one thing that's together. They're both part of the same problem. So you need the information in that. In question 16, you don't need to know. It could be a liter. It doesn't matter. It doesn't matter how much is here because we already have the flow rate. We just need to know what the drop rate would be.
Okay. Thank you so much.
You're welcome. And I did see 15. Yeah, that's a good question. So yeah, if it's when it's a flow rate question, it should be in milliliters per hour. And if it's a drop rate question, it should be drops per minute. So if it doesn't state specifically when they say infusion rate, it's milliliters per hour. All right, someone asked about 15, so I'll work through that real quick. And then I can do, if someone asked about the dopamine, if you want me to work that out, I can, or if you want to just watch it on the recording, just let me know in the just put it in the chat. Just let me know. So 15, it says calculate the number of hours and minutes 420 cc's of 0.9% sodium chloride will run if it's infusing at 120 cc's per hour. So what we're going to do is some clever math. So this is 15. We have 420 cc's, and that's infusing at 120 cc's per hour. 120 cc's per hour. And what we're going to do is we're just going to divide 420 by 120. Oh, sorry. I don't know why we can't see that now. There we go. Come on. There we go. Get my camera all confused. All right. So 420 divided by 120 gives me 3.5 hours. And then how they want you to write that is 3 hours, 30 minutes. Okay. If this was 3.25 hours, that would be 3 hours, 15 minutes. If this was 3.75 hours, it would be 3 hours, 45 minutes. Just so you realize what a quarter hour is, 3/4 hour. Just remember that it wouldn't be 3 hours and 75 minutes because that wouldn't make sense, right? Okay. And I think it'll either be a whole hour or up to the 30-minute mark, just in case. All right, are there any other questions?
I will say, if you want to do the dopamine again,
Okay.
I just had like a really specific question about it. I found some more online just to get more practice with it, and I was getting pretty much the right answer, but I was only off by a couple, maybe like tenths, if that. Like I was getting 15.33 and it was 15.3 for some of these answers. Do you have any tips for that?
Yeah. So, well, here was the thing. You had the right answer. It's just that typically you would round your answer to the nearest 10th. So I think for number 8, the answer in the book is 3.125 milliliters per hour.
Yes.
When I solved it earlier, I told you to round it to the nearest 10th, 13.1 milliliters per hour. So I'll just show you my work so you can see what it looked like. So when I initially went through 8, I took the patient's, or I wrote down the important information: 5 micrograms per kilogram per minute, patient's weight, and then the available concentration. Then we had milliliters per hour is what we were looking for. So what I did is I converted the patient's weight, or I took the patient's weight multiplied by the weight-based factor 5. I got 350 micrograms per minute. And then I went through and I converted micrograms to milligrams. And then I converted minutes to hours. And I did that all across like one area here. And then when I got to when I factored in and got to this point, this is where I think the answer should be 13.1 milliliters per hour, because you've been told ad nauseum to round to the nearest 10th. And I think that would apply here. I don't know why, because I'm most likely the one who created this practice test. For some reason, I can't find it in my stock of practice tests. But the key, if I were writing out your answer, I would write out the whole answer and then rounding it to this. But I do believe that this should be the correct answer, the 13.1 milliliters per hour rounding to the nearest 10th, because that's probably the only thing you could plug into the infusion pump.
Okay. Yeah, that makes a lot more sense, because I saw that too. And I'm like, I don't understand, 125.
Right. Yeah. Why was that there? And
Right.
that was, yeah, it may have just been at the time when I wrote it out, I may have just forgot to round it. And then that's probably why your answers were off, is because they're rounding to the nearest tenth, which I think is the correct way to do it.
Okay. And then my only other question about it, like I've seen people that do the weight calculation in their equation.
Mhm.
Now, am I gonna get into like a slippery slope here if I do it beforehand and then plug it all in?
What
Or
do you
should I
mean? Like
always,
if you
like-
do pounds to kilograms first and then plug it in?
yeah, it's like they add an extra step on some of these videos that I'm finding. They add an
Uh-huh.
extra like equation, and that's the weight. But I just do it like divided by 2.2.
Yeah, no, you're fine. That's
Okay.
like if I was when I demonstrate like on the videos that I put together, I usually don't add like an extra step. But if you're following dimensional analysis the correct way, you'd probably want to write all the different steps. What I do is I kind of like I think about it from the standpoint of cooking. I don't think you need to like, talk about all the steps. You just need to know you need to gather the ingredients. And one of the ingredients is converting pounds to kilograms.
Okay.
And also what I have found in most of the things that we do within the nursing department is that when you convert pounds to kilograms, you want to round that to the nearest tenth right then and there, and then continue on with your calculations. But you should still get the same answer, even if you wait and do the rounding at the end. It should still come out to the same answer. So
Okay. Thank you.
you're welcome. Good question. All right. Well, like I said, I will post these and this video and make it available. And then I have the evening that I'll be here as well. I think you guys are 6:15 to 7:15, and then I'll also be here on Thursday. So if you have any other questions, also feel free to email me if you have any other questions, and I'll try my best to straighten you out.
Thank you so much. That was such a great refresher.
Thank you.
Yep, you're
Thank you.
welcome. Yep, good luck, guys.
Thank you.
Thank you. Have a good one.